Hi, let's look at the last part of the network layer, and this will be an introduction to routing. Now, basically, what does a router do? A router has to make decisions as how a packet is forwarded. So what I need to do is say what happens when a packet gets to at a router interface. So when you look at this case, what happens to a packet that's sent from PC1, what happens when it hits the interface on router 1? So that's kind of what we're looking for as far as this whole sequence is concerned. Now, a router, really all it's worried about is what's the destination IP address. And then it searches its routing table to determine where to best forward that packet. Now, the routing table contains a list of all known network addresses. You may hear them called as prefixes, and where to forward that packet. Basically, what interfaces am I sending this packet out to get to that? Now, the router will forward its packet using what it calls the best matching route entry. So it's comparing the network address and find the one that has the longest match to make it best. So when a packet arrives at port gigabit Ethernet 00 on router 1 there, it first de-encapsulates the layer 2 Ethernet header. It examines the destination IPv4 address of the packet, searches its routing table for the best match, and then if that route entry indicates the packet is to be forwarded to router 2. So then it encapsulates a new Ethernet header and trailer and forwards that to the next hop router, which is router 2. So it's going to take information off of the packet coming in. It's going to look at it, analyze it, make a decision. If it's going someplace else, I'm going to re-encapsulate it with a destination IPv4 address and pass it on. Now, this routing table basically says I'm trying to find the biggest match. I'm looking at what is the next hop or the exit interface. What interface out of the router am I going to move this packet to? So when you looked at the whoops, I didn't mean to zoom that in. Let me reduce that a little bit. When you're looking here, the router table says, hey, I know that I've got the 192.168.10 network on that and on the .1 interface, and I have the routing table says I know about the 209.168.165.200.224 interface network someplace else. So it then says I'm going to have that information in there and says if I'm still going to get to that 10 network, because that's what the address is looking for, the routing table just says, hey, to get to this network, I know I've just got to go at that interface. And that's all this routing table is trying to do, is keep track of all the networks it knows about and says, I got to send it onto what? Onto the next router, router via 2. And that's really what the router is trying to do. It's just basically saying, I'm looking at my table and says, what information do I have? Do I have a next information? Now, a routing table stores like 3 types of information. It stores the routes that are directly connected. So if you have you're plugged in an Ethernet cable that connects a router, physically connected to that device, it's directly connected. So it knows about that. Then it knows about remote networks. Remote networks are connected to other routers, and the router learns about the other neighbors by exchanging information between routers using a dynamic routing protocol. And there are several of them out there that change data differently so that we can keep track of which networks do we want to know about. And then a default route, like a host, most routers also include a default route or a gateway of last resort. And you'll see both those terms used in some of the reports. But this default route is saying when there's no better answer, no longer match in the routing table, I'm just forwarding this message on. And hopefully somebody else downstream has better luck than I do in getting an answer. So in this example, you look at router 1, it has 2 directly connected networks, the 192.168.10.0 network and the 209.165.200.224 network. And those are the only 2 directly connected networks it knows about. But router 1 also knows about the 10.1.1.0 network because it was remotely connected, and router 2 says, hey, I'm going to share what routers I know about, what networks I know about, onto who's directly connected to me based on the routing protocols that we've done this. Now, I can learn about these remote networks one of 2 ways, manually or dynamically. Manually says, hey, I'm going to manually populate that table, and that's probably okay for small networks, or you're a very fast typist. But most networks, based on what you're doing, is going to be dynamically, and they are learned by some kind of dynamic routing protocol, which we'll definitely get into a whole lot later. Now, there's something called, there's 2 types of routing. There's static routing and dynamic routing. Static routing is a fixed, I've manually configured that address. And if I'm going to set that up, the command to do that, you can see it down below, IP route, and gives you the remote address, gives me the remote address of the 10.1.1.0 network and its subnet mask, and what is going to be the exit interface, the next hop interface out of router 1 to get me to that 10.1.1.0 network. So that is how to do. So this is what a static route you manually define. You type in IP space route, give it the network address that you're trying to go to, and the address of the next hop. Who's the next router in the sequence to get me to that destination? Now, granted, if the network changes or something goes down, static routes are a pain to have to go back and reconfigure. So more than likely, most people use a dynamic route. Let me just bypass this because it's an example of something going down that now I got to go back and tell R1, oh, you can't get to the 10.1.1.0 network via router 2 because the link between R1 and R2 is down. So then you'd have to manually change that route to R3, and then let it go back up. So static routing, it's manually configured. The administrator needs to reconfigure that route if anything changes. It's appropriate for small networks when there's very few changes or no redundant links, and it's commonly used with a DHCP, a dynamic routing protocol, for configuring a default route. So if you want to guarantee what the default route is, you set that up to be statically assigned. Now, dynamic routing it allows the routers to automatically learn about remote networks, including default routes, information from other routers. And this routing protocol allows other routers to share information and, of course, compensate for any changes in the network that's going on. There's a couple of dynamic routing posts. There's probably 2 that are most popular, OSPF and EIGRP. Both have different rules and methods and availability. EIGRP is a Cisco defined, but since there's other routers out there, actually OSPF has probably been industry use the most, only because of the proprietary nature of EIGRP. So much for that Cisco removed its proprietary labeling of the EIGRP protocol. So basically, router 1 is using OSPF and router 2 is using OSPF. And what it's going to do is let each other know about what networks it knows. So that, basic configuration, and we'll get to a whole lot more of this later, is it requires the network administrator to enable directly connected networks within a dynamic protocol to do it automatically, to discover remote routes, to maintain and update the information on the table, determine what is the best path between the different destinations. And it'll actually attempt to try to find that best path if the current path is no longer available. So it is trying to make sure all of those things take place at one time. So as in our previous example, when the link between R1 and R2 goes down, it says, okay, that was my previous best path. Something's told me that I can't get there. It now creates a new path going through route R3 to get to R2 to still get access to that, versus having to have a manual change done to the routing table. I would watch the IPv4 routing table video and go from there. Now, let's take a look at an IPv4 routing table and show you what types of things are there. So you got your brief diagram. Now, to display the routing table, the command you want to use is show IP route. And then it gives you, in the top section here, it gives you all the codes that it's going to list below, what protocol it's going to use, what its default is. Then it also says, what's my gateway of last resort? Otherwise, what gets me outside of this route? If I don't know about a route, where do I go? Where do I send it? Now it's telling me I've got a static route that tells me, hey, if I'm going to get to anybody else, I'm going to go out that interface, the gigabit 001 interface is where I'm going to find the rest of the universe. Then it proceeds to tell you which routes I have. So the O says I'm using OSPF. The C tells me that I am connected. The L tells me what? The L says it's a local connection, so it tells me that's the address there. So it gives you all the known networks, so it knows about the 192.6.8.10 network, and it knows about the 209.165.200.224 network. So it kind of goes through and explains everything it knows about. So you get this via the show IP route command, and then look at that header. The ones that are probably the most concerned is you got which ones are connected to you, the L. If they're to a local interface, if it's a C, if it's directly connected, S means it's statically defined, and then OSPF is an O, and EIGRP is a D. So you're going to pay attention to those commands. So hopefully that gives you a high-level introduction to routing. I would go ahead and take the routing quiz, this little check your understanding. And then for those of you, just FYI, for this module, there are no labs. So what I need you to do is do the module practice quiz, which is that 8.6 section. So you want to make sure you do that. So hopefully this helps a little bit.